can you make orange juice with apples? No? Oh, don't worry, we're actually making apple juice with oranges on this video.
No matter how difficult it may seem.
That means if I am getting this message, that means that I already passed all this, because at the destination blockchain, I got the Bridge NFT stored in the vault. It's already available for us.
The sacrifice.
Now we are waiting to get the approval to move the NFT using Retain NFTC, because we use the custom ERC20 token.
The sleepless nights.
That means that the NFT has been moved. Okay, NFT has been transferred to the bridge. Let's look for that message right here. There you go. In transit to destination. There we go. This is the message that we are displaying. Okay, and now we got the RPC address transferring via destination via the RPC.
The failures.
And we got transfer completed. Transfer completed means that I was able to confirm that the destination NFT has been sent to the user wallet.
Because at the end, it's worth it.
No pain, no gain. We have to build the JavaScript function that will bring the NFT bridge to life. And it's interesting. Yeah, we have to code a lot. We have to code a lot, but when we do something like this, you can feel assured that you are on the right path in Web3 development. Because building a function in React, NextJS, and a JavaScript function that will bring the bridge functionality to life. So the user, the only thing he or she has to do is press transfer and the NFT move from one blockchain to another. It's not an easy task, but it's not impossible, okay? And we're gonna make it happen in this video. I am going to make this introduction very, very quick because we have a lot to go through on this particular video. We are going to build the NFT Bridge JavaScript function that will allow the transaction to happen, all the way from retaining the NFT to releasing the NFT. If we need to bridge mint the NFT, meaning that at the destination, I don't have the destination NFT available, I have to bridge mint it. I have to mint the NFT on the fly and send that NFT to the user's wallet as well. We're gonna code all this magic behind the scenes, okay? We are also gonna provide the end user real-time status activity as the transaction is running. So we are going to display messages, awaiting approval, got the NFT in custody, all that information that we're going to display in the model. Once the user hits the transfer button, we are going to code that today. And we are gonna be almost done with the NFT Bridge application. It's a long video, but trust me, it's worth it. Let's go. Okay, so let's start working with the source blockchain, okay? So the first thing I'm gonna do, we are going to open the app and I'm going to show you what section are we going to be working with first. We need to obviously gather the information from the source blockchain. So we need the user to select the source blockchain that he or she is moving the NFT from, because we need that information so then we can continue executing all the process, okay? So this is the bridge. As you know, on the first video, I did a very cool intro. But don't worry, you're going to be able to run this yourself. Cool. Okay, we got the transfer from. So the moment I select the source blockchain, right, and I press retrieve the assets, what's going to happen on the back? It's number one. I am going to send a Web3 call, in this case to MetaMask, and I'm going to say, hey, I need you to connect, right? So let me open here. So I need you to connect onto the wallet, right? And once I connect to the wallet, there you go. I can already see the NFTs coming into the app. So the moment I connect onto the wallet, I am going to establish a Web3 connection. And from there, I am going to retrieve what information? I need to gather the blockchain ID, the chain ID of the wallet. Where is it currently connected to? If it's connected to a network different from Ethereum, I am going to send the request to MetaMask to switch the network to Ethereum, because we're going to provide that information. How do we get that information so that we can determine if it's on the right blockchain or not? We are using the MetaMask Detect wallet provider. With this, I know exactly what chain ID is the MetaMask wallet connected to, and I can actually make a call to switch that mainnet or testnet, okay? So in this case, Ethereum is mapped to the Goerli testnet. I am expecting the Goerli chain ID, okay? So in this case, I am indeed in the Goerli testnet, okay? So we're gonna be configuring that. Once we configure that, I will then retrieve the NFTs. So if you have not seen the video where I configure the entity pooler, this is the NFT pooler that I'm using to fetch that information. I am getting the IPFS metadata, I am getting the picture, I am rendering everything on the app by calling the NFT smart contract and sorting the output with the user wallet that is connected. So in this case, my user wallet, and let me zoom here a little bit more. My user wallet is this one right here. So I am basically calling the blockchain and I'm saying, well, if from those NFTs, the owner is matching this wallet, then display the NFTs. And that tells me that I am indeed the owner of those NFTs. You see where I'm going? Awesome. So we need to build this. We need to build this first, because once we build this, then I need to get that information and then I can determine what am I going to do on the destination, okay? So on the destination side, we need to do a lot of things. And the source instruction or the source function, if you have seen my previous videos where I am leveraging the Wallet Connect, so in this case, the multi-chain marketplace connect button, basically it's what we're doing here. And you're going to have the same functionality, okay? So we're doing that. And we're also leveraging the entity pooler to gather the art from the NFTs and the metadata so that we can display this on the app, okay? Good so far. Awesome. So now once we determine that, I can go ahead onto the destination side, and this is where all the magic will happen. Because with this, I am going to tell the JavaScript function, this is the destination contract that you need to use. This is the destination custody that we are going to be interacting with. Same goes with the NFT Bridge. I am going to send the instruction to the NFT Bridge smart contract. And when I say NFT Bridge, I mean the NFT token on the bridge on the other side on the destination, okay? So what I'm talking about is the NFT that we are going to allocate at the destination blockchain. If you saw the previous video, I actually went through the smart contracts, okay? So we're gonna be interacting with the destination contracts, okay? We are also interacting with the source contract because I need to approve the custody contract from moving the NFTs out of my wallet and retaining that NFT. And we talked about the retain NFT function. This is the most important piece of the bridge. I need to confirm that I have custody of that NFT before I can release the destination NFT. Keep that in mind. That is very important. And you're gonna see this right here. At least you're gonna see the function, okay? We still have to build the front end. That's gonna be the next video. And then after that, we're done. That's cool, okay? Cool, so transfer to. When I select transfer to, I am going to select the destination blockchain, okay? So I can select, obviously I'm not gonna select Ethereum. Hello. I am going to select Binance Smart Chain or Polygon, okay? Add the destination blockchain. I got to, again, like I mentioned, I have to tell the application, hey, this is a smart contract you're gonna use at the destination because the user selected Binance Smart Chain. You know what? This is the smart contract that you need to talk to. And we're gonna do that right now. Also, I added a feature to select if the user would like to use the N2DR ERC custom 20 tokens that we have been working so far on this channel, okay? So I can check the box, and that means that I'm gonna be paying with that token. If I don't check the box, I am going to be paying with the native Ethereum token because that's the source blockchain that I'm selecting. If I were to select the Binance Smart Chain, right? And you can see the moment I switch myself to Binance, it's going to tell the MetaMask wallet, hey, by the way, you got to switch networks. So I'm going to switch, and now I am Binance Smart Chain. If I retrieve assets, I should get the assets on the Binance Smart Chain. So let's see if we are lucky. Unless I don't have NFTs on Binance. I don't think so. Yeah, it doesn't like it. Doesn't look like I do have NFTs on Binance. That's fine. Okay, cool. So in this case, if I then select Ethereum as my destination blockchain, then the tokens that I'm going to be using will be the BNB, native Binance Smart Chain token. But let's say I want to use the N2DR. But again, the N2DRs have to exist in Binance Smart Chain. So it means that you deploy the contract in Binance Smart Chain as well. Okay, so you're going to be using those N2DR tokens in Binance Smart Chain. Okay, I am going to call useState, and I am going to get that value. So then I can associate the click to the token ID, and we're going to do all that. We're going to do that mapping. So now I'm effectively telling the bridge, hey, I'm going to be moving NFT ID 1 because I selected that one. If I select 4, I should be able to refresh to 4. This is using React useEffect. This is using React useState. Okay, good so far. Awesome. Let's do some coding. Okay, so what I'm going to do now, I'm going to open my Virtual Studio Code, and we're going to start coding here. Okay, bear with me. Let's do it. Okay, let's build the source function. So this is the function when I selected the source chain. Okay, so when I select this right here, right, and I retrieve the asset, this is what we're going to configure. Let's go. So here's the first thing that I got to do. I am going to call the Web3 model because I need that node module so I can interact with my MetaMask wallet. I am going to create provider A. I'm going to connect. This is normal Web3 connection. Okay. From there, I am going to store accounts. The first account that it retrieves from the call, that is the account. This is the wallet ID. And then I am going to display the wallet ID in the front page. And this is right here. That is exactly what we're doing. This is displaying the wallet ID in the front end. And this is how we do it. Okay, so I know that I established a successful Web3 connection because I have the wallet displayed on screen. Okay, now here's the fun part. Okay, check this out. Now I have to determine, okay, I got to determine what chain is the wallet connected to. So the first thing I'm going to do, I'm going to create the vars, right? Goerli, Mumbai, and BSC testnet, and I'm going to provide the values in hex. Right? And you have seen this on my previous video. On the marketplace video, I coded the connect wallet button. Go and watch that video so I don't spend too much time re-explaining this. Basically, what I'm going to do, I am going to retrieve the values using the tech wallet provider with the MetaMask API. Okay? So now what we're going to do, we're going to connect. And this is where I invoke the API. So I'm creating a constant call connected. I am going to call the MetaMask detect Ethereum provider. Okay, and with that I can determine what chain is the wallet connected to, and from there I'm going to paste all this. Right, I want to make sure that I go fast because we have a lot to work with. Okay, so the first condition that I'm going to confirm once I get the information from the wallet, right, once I get that wallet ID, I am going to say, calling the API, this is using the API, I am going to invoke connected, which is calling the detect Ethereum provider, right? And I'm going to retrieve chain ID. What is the chain ID that you are telling me? Okay. If the chain ID is equal to the Goerli chain ID, that means that your wallet is connected to the Goerli testnet. Okay. Which means that I am going to set the source NFT var. I created a set of vars that are the smart contract addresses for that particular blockchain. Okay, the first var is the source NFT contract. This is either the bridge NFT or the actual original NFT collection smart contract. Okay. Remember, you're only going to have one collection smart contract. That is the smart contract that you deploy initially and users bought the NFTs from. Okay. The other blockchains participating in the bridge are going to have the bridge NFT smart contract because we're replicating the NFTs, the original NFTs at the destination blockchain. Okay. This will store the custody contract from the source blockchain. Okay. And you know, we already explained that on the last video. In this case, if my chain ID equals Goerli, that means that we are going to set the source custody contract to be the Goerli custody, Goerli NFT RPC, because now I know that when I make calls to those contracts, I am going to call them using the Goerli RPC because that's where they live in that testnet. Okay. And if I'm going to use the ERC20 token into the rewards, I also need the smart contract because I need to send the request to that ERC20 token to transfer those tokens to I can pay. Okay. Okay. This is the case if the source chain active on MetaMask matches Goerli. If it doesn't match Goerli, then else if the chain ID matches Mumbai, then do the same thing instead. Do it with Mumbai, just associate the same vars, okay? Instead of associating to Goerli, you're gonna associate them to the Mumbai contracts and Mumbai RPC. Else if the connected chain, if it doesn't match Mumbai, then I'm gonna go to the next one. Does it match BSCT? If it does, then instead you are going to update those values with the BSCT contracts and RPC. That's it. We're going to go if else, if else, if else. If, you know, one of those three. So whichever is the one that the user selected, then we are going to update that source contract that way. Okay. All right. Now, provider. We are going to start calling those smart contracts and we're going to do some magic. By the way, this should already be familiar to you. So I'm going to copy it. If it's not familiar to you, I am going to leave in the video description the link to the NFT pooler because this is what we're doing now. Okay, check this out. Once I determine which chain is the wallet connected to, then I'm going to update the vars and now I'm going to make my calls. I am going to create a provider constant. This will store the JSON RPC provider call in Ethers to use sRPC. So let's say I selected BSCT. sRPC is going to match BSCT RPC. So now I'm calling BSCT RPC as the source blockchain so I can interact with that testnet. Okay. And this is storing my owner wallet. Okay. The owner wallet, what's the wallet that I used to mint those smart contracts, to deploy those smart contracts. Okay. So I need to make sure that I tell the application, in this case, the NextJS application, using Ethers, I need to interact using the owner wallet because the owner wallet will be the only one that can call those functions to bridge and so forth. There's one function that is called by the user, which is the retain. Obviously, we cannot do that call on behalf of the user, but everything else, it's being executed with the owner of the smart contract. Okay, and this is how we store that. Okay, now the contract. What contract am I going to talk? Source NFT, invoke NFT ABI. And again, I already went through this, explained that on that video. Check the link below. Calling the item array. Now, instead of me on the last video, I was looking at the total supply of NFTs and iterating over each ID. I found a better way and I was like, wait, I should have do it this way instead. So instead, I am going to call wallet of owner account. What is the account? Remember when we first got the account address that the user got connected? You know, the wallet that the user got connected? Now I'm going to invoke that into the contract. What contract am I going to make this call? Wallet of owner. I am going to make that call to the source NFT smart contract. This is how I'm going to know what NFTs is the user holding on that wallet. You see? Once I get that information, I am going to make sure that I can display the pictures, I can gather the IPFS metadata, and I can get all that information so that I can push that and display that on the Web3 front end, on NextJS. Okay? And already, this is all part of that NFT puller. So you might want to take a look at that. It's very cool. Okay? Once I execute all that information, I get all the stuff that I need to display the NFTs, right? And make my source connection. Now I'm going to store all those values using useState. So I created a useState call, get source NFT, and this will store the source NFT smart contract address, the ERC20 tokens smart contract address that we are going to be interacting with at the source, so the users can pay using that token, and the source custody as well as the source hierarchy. Why am I storing this as a useState? Because I'm going to use that in the actual bridge transaction. I have to interact with both the source and destination blockchains, okay? And the last one, it's basically for me to store the entire item array, all the NFTs, so then I can sort that and display that on the site. That's how I'm displaying my NFTs. If you could go back here, this is how I'm actually displaying this, which is kind of cool. Okay, cool. Let me continue. So now with this information, right, all I have to do, I have to create my useState, and I'm going to be doing that over here. Not going to do it now because we still have to build the front end. There's no way to test this until we build the front end, okay? But I want to go over each function because this is the most important thing. I think in the entire project, this is the most important thing, okay? So we have built the source call. Let's gather the information from the source. Let's determine what NFT smart contract, what custody smart contract am I going to use, and what ERC20 token, as well as the RPC, okay? Once we get that, we are going to build that insane transfer function, okay? Let's go. Let's take a look at the transfer function. And the transfer function is basically the magic behind the bridge. How can we accomplish bridging from one blockchain to the other? So how can we move an NFT from blockchain A to blockchain B? Let's make it happen. So I'm going to begin, as I always do, by getting the information in. Okay, so let me go ahead and paste what I'm going to do. Okay, so what I'm doing in the transfer function, and this is an ASIC function called init transfer, I am going to determine what selection will the user, what blockchain will the user select in the destination dropdown menu. Let me show you that real quick. Okay, so let me show you real quick. So when I retrieve assets, obviously I'm gonna get the NFTs that I'm holding in the Ethereum blockchain with my wallet. When I choose a destination blockchain, that is the information that I need to obtain. So then I can determine what destination custody and what destination NFT bridge smart contracts am I going to be interacting with. So the moment the user selects one of those three blockchains, I need to tell NextJS, hey, by the way, this is the destination custody contract and this is the destination NFT bridge smart contract that the user must use. Okay, so we are going to append the values to the variable so then we can make the calls with ethers. Let's check this out. Okay, so let's say I'm going to select Binance Smart Chain. Okay, so once I select Binance Smart Chain, this is what's going to happen. So I need to get that information, the input from the user in the web front end, and determine if the selection was BSC, and you're going to see that I have an ID on the dropdown for Binance Smart Chain, and this is what it reads. So if that input reads a Binance Smart Chain, it means that your destination blockchain will be BSC, which then means that I need to append to decustody the smart contract address on the Binance testnet or BSCT custody smart contract. We are going to configure and export the variable that will store the address for that particular contract address, okay? So, and the same goes for the destination RPC. So this is the destination blockchain RPC address. Also, this is kind of cool. So what I ended up doing was at the end of the transaction, I am going to give the opportunity to the end user to see the transaction receipt on the Block Explorer. So on the destination Block Explorer, I'm going to provide the user a quick click here link that will take him to the Block Explorer to see more information about the transaction. So this is how we confirm that the transaction was successful. So I am going to provide this. And by the way, this all will be auto-selected. Once the transaction completes, I'm going to generate the link at the end with the transaction hash ID that the user just needs to click, and it opens automatically, and the user can actually see the blockchain transaction in real time. There you go. And again, we're doing the same thing. Polygon, Poly, and we are mapping ourselves to the Mumbai custody, the Mumbai RPC, Poly NFT, etc. So, and the same goes for ETH. So if my destination blockchain is Ethereum, then I'm going to map myself to the Goerli custody, the RPC, Explorer, Goerli NFT, and so forth. Okay, it's very similar to what we did on the source. Now, here's the fun part. I'm going to show you what am I going to do right now. So I'm going to paste all this, but bear with me. Okay. So the first thing that I need to determine is token ID, okay? So token ID, what do I need to use this for? So token ID, I am going to use this variable to store ID. What's ID? The token ID, okay? So when the user, let me pull it back. So when the user clicks the NFT, the value will be, the value of ID will be the token ID of the NFT. You see where I'm going? So if I click 1, token ID 1, obviously, this call, it's being done on the front end, right? On NextJS, I have an input that basically says, if I click this, assume it's 1. How am I mapping the number 1 to this particular object? Through the token IDs. I am obtaining the value for this token when I make my first source call. So when I obtain the NFTs from the source blockchain, I am going to retrieve the token ID and I will store that in an object, so then I can reference that object and use it. So then the user can just click and select the ID, and we will automatically grab that input and store it onto ID, which then on the call itself will be done to token ID. So the moment I click that NFT 1, this value of ID is 1. Which then token ID will be 1. And again, I am opening Web3 model, connection, await, creating the provider, the signer, the user wallet. Okay, so this is basically me obtaining the address of the user wallet that is connected, because I need to tell the destination custody smart contract, this is the destination wallet that you should be sending the destination NFT to, or the bridge NFT. Okay, so that's how I am going to obtain the destination NFT, or my NFT at the destination of the blockchain. Okay, cool so far? Awesome. Provider. Now I need to make an RPC call to my destination RPC address. Okay, so if we select it from Ethereum, this is my source, to Binance Smart Chain, destination RPC, it's going to be Binance Smart Chain. How did we determine that? I'm actually refreshing. I want to make sure that you are following me. How am I going to determine what the RPC value will be? Like I told you, I need to see what the user will click in the drop-down menu. And based on that, I will know what the destination blockchain he or she wants to transfer the NFT on the bridge to. Okay, so in this case, we select the Binance Smart Chain. So that means that I am going to send the NFT to the Binance Smart Chain, and I need to do that RPC call. Okay, and here I basically, if you haven't seen my previous videos regarding the NFT marketplace, I am doing basically the same thing here. I use simple crypto. Again, I'm not saying that this is the way you should do, but it's a demonstration for me to show you how to you can cipher the private key, but you have to be very careful. Like you don't want to show this in clear text, or at least with a weak cipher algorithm, like encryption algorithm, because it could be easily breakable and you can lose everything, which is basically the private key of the owner wallet. This is the wallet of the owner of the smart contracts, not the wallet of the user that is sending the NFTs. The smart contract owner. Okay, good so far? Cool. And basically we create wallet, which basically I am creating a wallet using the private key, creating a wallet, and then I can interact as if I was the user that was triggering the calls or the functions on the smart contract. And those are the functions that only the owner of the smart contract can talk or can call. That's why it can only be called by the owner of the smart contract. Can you imagine if we let anyone release NFTs? I'm like, that's it. I'm like, no security at all. Yeah, you're done. So you don't want to do that. You want to make sure that only the owner, and we configure that on video number 2. We set the security that only the owner of the smart contract can make those calls. The only call that a user can do, let's repeat, the only call that I'm going to allow a user to do in the bridge will be to retain, never to release. We cannot allow a user to release. We can allow a user to retain. So the user sends the NFT and he or she will actually make that call, but not to actually release the NFT. You don't want that, okay? Cool. Okay, and now I am also making a call to the source NFT collection smart contract. This is the smart contract that I'm going to be transferring from to the custody vault and the source blockchain, okay? Which means that this is the address of the NFT collection that I'm sending the NFTs from. Why am I doing this? Because I have to send approval for all. So I need to allow the bridge to move the NFTs out of there onto the custody. But first I have to approve that as the user. Like no one can just move the NFTs without your approval. You have to approve the smart contract to do that. Okay, so this is what am I doing? I am basically creating that constant to do that. I am also creating another constant called token contract, and this is for the custom ERC20 token smart contract, the N2D rewards in this case. So if anyone wants to pay the transaction fee using the custom ERC20 token that we minted on the channel, then they can do so. They can do it this way. So I am not only tying the bridge to be used with a native token, I am actually using custom ERC20 tokens, which is even cooler. Now you can pay using your own custom token. And now we got the Ethereum NFT custody smart contract, and this is the destination custody smart contract. This is where I am going to be releasing the destination NFT from. I move NFT number 10, right, from my wallet to the source custody smart contract on the bridge. The moment I obtain confirmation that that NFT was moved, guess what? I am going to send a call to move the destination NFT. In this case, the destination NFT is going to be held in the destination custody contract. If there is no NFT minted at the destination, what I need to do first, I need to make sure that it's minted before transferred to the user, because we need to have the NFT, else the user is not going to receive anything, okay? And we will do that. The user will not see that. This will be done on the fly only one time. The first time that that NFT is transferred using the bridge, we will mint the same NFT at the destination. That NFT will be there forever. If the user wants to move it back to Ethereum, that NFT goes back to custody, and then he or she receives the NFT at the destination blockchain, okay? And finally, obviously, the destination NFT, and this is the bridge NFT smart contract. This is not the source smart contract. This is the bridge NFT. This is like the duplicate NFT that we are going to provide the user at the destination blockchain. Got it? Awesome. I am going to add this. I'm not going to explain it now because this is part of the graphical interface. the web front end, but basically this will open a model, a small box that is going to show in real time the status of the transaction, which is very cool. So when we click transfer, it opens that model. That's the handler, and we're going to be configuring this in the web front end video. Okay, cool. Now let's go with this. Let's go to a party. Okay, so I'm going to show you this cool thing that I'm going to do now. Okay, here's the magic. We just built all my variables that I'm going to be interacting with, all the contracts, all the wallets, you know, the user interaction, all that. Now we are actually making magic happen. Okay, so the first thing that I'm going to do, first of all, I set up a timer. Basically, it's a timer to await for like a second, so I can obtain all that information, like not just go too quick. So it's just a second. After that, I am going to display initializing transfer. This message, this string, will be displayed in the model. So when you click, the first thing it's going to show is initializing transfer. I'm going to show you how to display that, which is kind of cool. Okay. And by the way, this is the information that I need to call with get element by ID. By the way, this is how we reference this string down into HTML. So then we can display that in the page. Okay. So I am basically creating display confirm 1. This is mapped to initializing transfer. I am going to use this value down in HTML on the model, so then I can display that message once the bridge starts. Okay. And all the messages are going to be displayed in a symmetric order as I continue processing each function or each call. I'm going to send messages, and that tells me, hey, everything is going well because I'm seeing those messages running. That means that we haven't broken anything in the path. Everything is going smoothly. I am seeing all the messages. And also we are providing the end user the status of the transfer. And as we continue, right, now I need to determine, is the user owner of that token ID 1? And you might say, well, if he is holding that NFT, that means that he's the owner. I'm like, no, but I need to make sure that he's the owner of the smart contract that we are allowing bridging. Because let's say if someone mints an NFT collection and we don't check against the smart contract that we are intending to provide bridging services, then anyone can spoof the token ID. Like I can mint an NFT from another contract and it has the same token ID. If I don't check if you own that token ID against the smart contract that we will provide bridging services for, guess what? That user basically exchanged something that is worthless to a real NFT, right? And you don't want to do that. You want to make sure that you want to make sure that the user owns the NFT from our collection, and he's not, or he or she is not trying to scam us, right? So that's why we need to check that the holder is the owner of that token in the smart contract, not any token, okay? I need to make sure. This is how I'm going to determine if the NFT of that particular user it's already minted at the destination blockchain, meaning that I do have a copy of that NFT minted at destination. If I don't have a copy, that means that that NFT has never been moved on the bridge. On the bridge, there has never been a transaction with that particular token ID. I am going to check that here. I am going to validate against the bridge NFT smart contract. If the same token ID, there's already an owner attached to it. If I make this call and I receive an error, if I catch an error saying that I cannot find that token ID, then that means that that token ID is not available at the destination blockchain. And what am I going to do? Okay, you told me that. Perfect. Now I need to send a request to mint that NFT at the destination smart contract. So let's go ahead and do that. Now I'm going to await, right? And first of all, I am opening that request, right? Check this out. I'm gonna paste this whole this whole procedure right here, and we're going to test this. So we're going to go to each section, and I'm going to show you as I am bridging an NFT. We're going to go to each section, and you're going to see this live on the video. So wait for that, okay? Wait, I think I did it that. Okay, perfect. So now I am going to await destination NFT. Basically, that's the smart contract for the bridge NFT. Owner of token ID. Okay, I am the owner of token ID 10. I'm going to check myself if the NFT is available at the destination. If I get an error, like it says, by the way, this is how you can trigger an action based upon an error or a result of this particular function right here, or call. So I can say catch errors. If I catch an error, then you want to do this. What am I going to do if I get an error? If I get an error when I do this call, that means that the token is not available at the destination. Okay, perfect. That's no problem. Now we're going to build a constant in which I am going to create a transaction. By the way, this is how we populate transactions in Ethers. Basically, I'm going to call destination NFT contract. This is the bridge NFT smart contract, populate transaction, and I'm going to call what? Bridge mint. Bridge mint is the function that you have seen on the previous video. That is the function that is going to mint the NFT at the destination blockchain. That function can only be called by the owner of the smart contract, no one else, because I am not going to charge the bridge to mint that NFT. It's free, but it's free only for the owner of the smart contract, meaning the bridge, okay? And I am going to tell Bridge wallet will be the destination address in which you should send that NFT to. And you're going to say, well, why we're not sending it to the custody? No, because I need to transfer that to the custody already with some owner associated to it. In this case, will be the bridge. The bridge will be the owner of that NFT until I get confirmation that that NFT has been migrated onto the source custody. Then I'm going to release a destination, but there's already an owner associated to it. You see what I'm going? I need to have a record of that NFT being on the custody smart contract. That's how it works, okay? And obviously a token ID, and this is how we can mint custom IDs. If you saw in the previous video, I actually minted an NFT that was random. Like, we're not minting in order, we're just minting random numbers. And now I'm going to get confirmation that the transaction was successful. And what I'm going to display in the browser console is bridge NFT has been minted at destination, meaning that the NFT now has been minted. It has been transferred to the owner of the smart contract, not the custody, not the user, to the owner of the smart contract. Okay. Now we are going to auto approve, right? And when I say auto approve is because this is currently being done on the backend with Ethers and the owner wallet, which is already created in the application. Like, I'm not going to manually say yes every time that someone sends a transaction in. I'm just going to auto approve it, right? So what I'm going to do, I'm going to approve the destination custody smart contract to move that token ID now. So from my wallet, the contract is going to transfer that onto the vault. And this is destination smart contract. Okay, and again, I am going to wait for that transaction to complete, transferring NFT to destination bridge custody. Now, if I get this message on the log, I know that all of this has been done successfully. Okay, so I already passed all that. And then I'm going to say console log transferring NFT to destination bridge custody because I already passed all the other functions or calls, okay? Now I am going to prepare a function, and this function will retain the NFT in the custody. This is not the source NFT. This is, by the way, the destination NFT, okay? So if you go up, this is the object that I created, or the var, that is storing the information for that contract. So let me go up, ETH NFT custody. Let's go up, ETH NFT custody is the destination custody smart contract. So now at the destination smart contract, at destination custody smart contract, I am going to retain token ID that I already minted. By the way, this is the token ID that I just minted up here with Bridge Mint. So now I'm going to move that to the vault at the destination blockchain. And I'm going to pass an option for gas because I have to be specific in this particular call. It requires gas. So I'm just going to put the gas limit, which is a required call or required value in the transaction. Then I'm going to await retain NFTD, which is basically, wait for this to complete. So then I can confirm that you got the NFT at the destination. Okay. Once you're done, and I was able to obtain confirmation here, then I'm going to display NFT successfully transferred to the destination custody. But this is on the console log because the user doesn't need to know that I'm minting an NFT at the destination blockchain. He doesn't need to know. He doesn't care. All he cares is that he gets the NFT. Okay, so now we know that if I pass this, the NFT is awaiting at the destination custody. So now we got the NFT waiting for that user, okay? Which is awesome. Now, check this out. This is the other scenario right here, okay? I told you, this is not simple NFT transfer. There's a lot of stuff going on this, okay? So in this case, now else if bridge holder. Who's the bridge holder? Bridge wallet, okay? Now, let's say, right? Let's say the NFT is minted, but it's not in custody. I need to make sure that I confirm bridge holder equals bridge wallet, okay? So let's say the NFT is minted at the destination, okay? If bridge holder equals bridge wallet, let's look and see what bridge holder is. Let's go up. Bridge holder will be the owner of token ID, right? At the destination, not the source. So whoever is the owner of that NFT, I'm going to store that into bridge holder. And I want to make sure that check this out, if bridge holder equals the owner of the smart contract, then go ahead and proceed to do this. I want to approve the NFT to be moved by the custody smart contract. The only difference here is the NFT already was minted. We're not minting it from scratch. The NFT was already there. It was minted, but it's been held by the owner of the smart contract. Why do I do this? Security. So let's say for some reason the NFT was transferred. Let's say the scenario. I change ownership. Okay, so I change ownership in that smart contract. Let's say you transfer ownership to someone else, okay, or some other wallet, or for security reasons, you want to change the owner of the smart contract. You want to refresh ownership of that smart contract, which I think is a very good security measure. Like, you don't want to keep the same wallet because you don't know if the private key was compromised. By you refreshing the ownership, you're clearing any possibility that the private key was compromised somewhere. And you're proactively, it's like changing passwords. You don't want to leave the same password, right? So you change ownership of the smart contract. If we're talking about DeFi, we're talking about a very, very important platform. For security measures, like you're working on a Web3 dApp firm. You're working on a Web3 development firm. You got an employee that was fired. The employee has probably private keys for the smart contracts. What do you need to do? You got to change wallets. You got to change ownership of those smart contracts. So make sure that it's not compromised. Same goes here. I got to make sure that if I want to change ownership, right, I can go ahead and refresh the NFTs and the owner of those NFTs. This is not just moving NFTs like I told you guys. There's a lot that you have to think about here, okay? Cool. So we got bridge approved. We're basically going to do everything except minting, because at this point I'm expecting that I already have the NFT minted, right? Okay, good so far. And let me know if you have any doubts, any questions on this one, because it's kind of tricky to understand what is going on here. Let me know in the comments, okay? But again, I have the NFT. I want to make sure that the bridge holder is the owner of the smart contract, right? So I am assuming that you already updated this if you change the ownership of the smart contract, because the bridge is not going to work, right? So enough with the talking. After I am done with all those conditions, this is quite an app, okay? If confirm holder equals user wallet. So now if let me show you where this is configured. Let me go up. If confirm holder, meaning that it's the user who's trying to move the NFT from the source blockchain to the destination blockchain. The same one in user wallet, meaning that is it the same one that is connected? Let me go back. Let me circle back again. If confirm holder, I need to check on the source NFT smart contract, the collection smart contract. I need to check if the owner of that token matches the user that is connecting to the bridge. I got to check that because I got to make sure that he or she is the owner of that NFT. If so, then proceed. Okay, get holder, hold custody. Now we need to identify at the destination custody smart contract who is the owner of that token. I already checked the source. Now I got to check the destination smart contract. Let's say at the destination blockchain, there is no owner whatsoever. It's 00000, meaning that it's unlisted. That could be because of the NFT collection minting and transferring to the custody smart contract without any owner associated to it. And this is another security mechanism to avoid a transfer that was done not in a correct way of doing it with retain. So let's say there's no owner to that. I still have to be able to take out that NFT. Okay, this is more like a backdoor, but a backdoor that will only work for the owner of the smart contract. It's not like anyone can spoof itself. Okay, so this is in case I move the NFT to the smart contract. Oh my God, I used the transfer from, or I used safe transfer from, or something like that. I didn't use the retain NFT. Then I can still get it back. Okay, if confirm holder matches get holder. So the holder, I have a struct in the smart contract, in the custody smart contract on the vault. Let me pull the smart contract because this is the only way you're gonna know about it. I'll make sure that we're good here. Yeah, it looks like it. And let's go to repos. Let's go to the bridge. Okay. Now we're gonna go to part 2. Okay, let me open this. I'm gonna show you right now. And we're gonna go to the custodial smart contract. So you can see here, I have a struct called custody. You can see it right here. This struct called custody has an entry called holder. In the Web3 app, let me go back. I am expecting from that call to obtain the value of holder. Now I have to make sure that if confirm holder, if the owner of the token matches the holder on the custody smart contract. Okay, because I need to know who put that NFT there in the first place, in the custody, right? So now I have to determine if the one that is connected to the bridge is the same one that it's intending to move the NFT from, the custody smart contract, okay? That's why I'm doing that. If that is being confirmed, that the user who connected to the application is the same one that is trying to move the NFT, user confirm, okay? So we know that we're good there. Else, if get holder, it's equal to unlisted, meaning that 00000, user confirm, no updates needed. And the reason why is because no one is owning that token, but the token is available in custody. And the reason why you want to do that is the moment we move that NFT, then I can update that record and say, okay, now you own the NFT. Like I am updating that in the custody, saying that now you own that. I can change that value on the fly. Else, okay, if I'm not matching anything of that, then go ahead and update the owner of that token ID to whoever connected to the bridge. And this is how you know where this will make a lot of use? If I sell the NFT at a destination blockchain. Why? Because the moment the wallet owner, the owner of the wallet changes, remember at the custody smart contract, I did not change ownership. The old holder, it's still the owner of the NFT on the custody contract, but on the token smart contract, it's not because I changed ownership during the transaction. So if I sold the NFT, now the owner on the NFT collection is different from the owner in the custody smart contract. Guess what? I got to update that on the custody vault as well. The only way that I'm going to be able to do that is if the user decides to move the NFT on the bridge. If he or she decides to move the NFT on the bridge, I am going to update that user to the new holder. That's all I'm going to do, okay? And you can see I'm going to get a message saying holder address updated to user wallet, okay? I'm going to make another transaction, and we're going to test all the scenarios. You know, migrating from one blockchain to another, selling quality NFT from one wallet to one wallet, then moving the NFT back as another user, so you can see it works, like, because I'm making sure that I'm doing those checks. Let's continue, because this goes on. This is a single function, okay? But I think we're 75% complete, okay? So let me go back. Okay, now we are starting the action, finally. Okay. Now, this information that you are going to start seeing here, verifying details, this will be displayed on the model. So when the user hits the function, and I already did all those pre-checks, right? Now I'm going to be verifying details. Now, please, verifying details. Okay, I'm going to wait for 4 seconds. Then I'm going to say status, verify, bridge initialized, meaning that I already went through all that checks, right? So this information will be shown after I confirm this. Then I'm going to start. This one, approve the NFT transfer to the bridge. What am I going to do now? You see how many calls I'm doing here? Now I'm going to do another call. Ethers contract, source custody. Source custody, guess what? That is the smart contract that is going to hold my source NFT. My real NFT is going to be held in that custody, right? I'm going to obviously use the custody ABI, and then signer, which is my wallet connected through MetaMask. Then I have NFT collection set approval for all, right? I am allowing the source custody to move that NFT on my behalf. And so it's going to obtain the NFT. It's going to retrieve the NFT out of the wallet and throw it in the vault, okay? Okay, cool. Now we got approval to transfer the NFT. So we got the approval to transfer the NFT, and approval to transfer the NFT has been received. The user already approved the NFT to be moved, okay? So I've received that approval. Now I'm going to continue. Now I'm going to execute the NFT transfer to the bridge, okay? So let's go ahead and do that. And you want to use the custom ERC20 token. Let's add more calls. Okay. Oh, you haven't started DeFi, by the way. We are literally building an NFT bridge, which you might think, oh my God, there's a lot of stuff going on. This is nothing compared to DeFi. Like I'm telling you, this is nothing compared to DeFi. But we're going to get there, okay? Awesome. So now, if custom pay equals true, custom pay, if I did this, check this out. If I went to the app and I click this, there is a use state that will track if the user check box here. So if the user did a check box, it means that custom token is being used. Okay, so then I'm going to determine that on the call if custom pay has been set to true, because once I do the check mark, there is a Boolean condition that will be mapped, either false, there's no check mark, or true, there's a check mark. Then that means that the user wants to use a custom ERC20 token. So I am going to obtain the value to transfer the NFT based on what I set on the custody smart contract. And you remember in the last video, custom? Let me show you if you haven't forgot. If you forgot, and this is just the native, but let me see. This is with custom ERC20 tokens. And there you go, cost custom. So now I'm going to obtain the value of cost custom, okay? So once I obtain the value, then, right, I make the call and I get the value. Now we know it's 1 Ether. In this case, 1 entity reward token. Then I am going to display, confirm, please execute the NFT transfer to the bridge. I'm going to display that on the model. Then I'm going to approve source custody to get my tokens. This is not to approve the NFT move. This is to move the ERC20 tokens from my wallet to the smart contract. So I am sending the call to the token smart contract, the N2D rewards smart contract. Hey, I'm approving you to move my, my funds. And once I obtain approval, I am going to say approval to transfer, transaction fee, payment received. I am going to show that on the logs. And then I'm going to proceed to retain the NFT, but using the custom function, okay? Which means that I am going to retain the NFT, but using the C, which is the custom ERC20 token, which I have a completely different function to perform the fund transfer to the smart contract. And you saw that on the last video, okay? Else, if custom pay, meaning that else, if this is not true, then it's gonna run this instead. What is going to run? Cost native. Then you're using the native token. That means that you didn't select the custom ERC20 token. Now I'm gonna need to obtain the value for cost native. At that point, it's just gonna go to the smart contract, call this function, and call this public var with the getter. So a getter will basically obtain this value and say, oh yeah, this is the amount that you need to pay on the native token. I'm gonna go ahead and do that. And we are going to execute retain NFT N. Okay, good, awesome. So now if this is successful, that means that we have successfully obtained custody of the source NFT. But we're not done yet. Oh my God. No, actually, this is the last thing. I promise. I'm tired. Trust me, if there's no passion, you cannot do this. Okay, let's show you. So, okay, so I confirm either with the retain NFT C or retain NFT N. I confirm that I got custody of the smart contract. Now we got to give the user the destination NFT. Let's do it. Now I know destination has been, the NFT has been transferred to the bridge, and now it's in transit to destination. I am showing that in the model, okay? Then I'm gonna show this on the log saying transferring destination. This is for us to look at the logs, right? To see that it's being sent to the destination RPC. Now I am going to call the custody smart contract, and we are going to finally release the destination NFT. We got the destination NFT held in custody. Now we need to release the destination NFT. Now, once we trigger this call, we are going to send the following. We are going to send the token ID, obviously. We're going to send the user wallet. Hey, this is the destination address that you need to send that NFT to. And we will await for that transaction to complete, and we get the receipt from the transaction. If we do get the receipt, it's party time, meaning that we were able to send the NFT to the user wallet at the destination blockchain. We're just going to send all this information out and display this in the model and on the web front end, okay? And that's it. I'm going to show all that information and done, okay? At the end, I am going to confirm out. I am going to provide the link. So then the user can click that link and open the block explorer and see the result of the transaction if he or she wants to confirm more details, okay? And that's it. And at the end, I'm gonna recall or refresh the state of the NFTs. So what basically this will do is just refresh the NFTs on the back in the source blockchain. So you should see the NFT that was moved no longer showing in the web front end, unless you move yourself to the destination blockchain as the source, and then you should be able to see the NFT there, which is kind of awesome, okay? So this is the whole process, ladies and gentlemen. This is the whole process. You want to do an NFT bridge? There you go. God, you gotta love this function, okay? We went through every single thing. To finalize the video, let's do a bridge transaction and let's see the steps in action, okay? Let me go real quick. Let's see how can we do it. So let me see if I can put myself on the right side. Okay, so I'm gonna do the following, right? I'm going to go all the way to the top. Let me minimize this a little bit more. Okay, so now I am going to literally select one NFT. Let me retrieve the assets. And I am going to select NFT. Let's just select NFT1. Let's just select NFT1. We're going to go to Binance Smart Chain from Ethereum. And we're going to pay using the custom ERC20 tokens. Enter the rewards. Now we're going to hit the initialize transfer. So when I hit this button right here, this is what's going to happen. All this. Okay. So let's take a look at that. Transfer. Okay. Initializing transfer. Let's find that. Verifying details. Okay. So we're verifying details. Initializing transfer. You can see it right here where I'm hovering. And that means if I am getting this message, that means that I already passed all this, because at the destination blockchain, I got the Bridge NFT stored in the vault. It's already available for us. So right now it's showing please approve NFT. So let's find that message here. And please approve NFT. You can see it right here. Okay. Now we're going to approve the NFT. Confirm. This is approving us to move the NFT to the custody vault. Okay. Now we get that. By the way, I'm going to show you the console logs. So user confirmed. You can see it down here. You see, user confirmed. Approval to transfer NFT received from the user. Approval to transfer NFT received from the user. We can see it on the logs right here. Now it's asking us, give permission to access your end to the R tokens. Okay, let's see that message where it's actually asking us to move those custom ERC20 tokens. There we go. Please execute. You can see it on the back. Please execute NFT transfer to the bridge. And now I am going to display approval to transfer NFT received from user. And now I need to pay. So I'm going to go ahead and pay. So I just paid. And now, yeah, you can see this message right here. Approval to transfer NFT fee. Okay. Now we are waiting for this call to be approved. Once we get the approval, boom, we got the approval. Okay. Now we should see this. NFT has been transferred to the bridge. I'm going to pay the transfer itself. Okay. So the first call that I got the approval was to move the tokens, to move the custom ERC20 tokens. Now I am going to get the approval to actually retain the NFT. So you can see that. So I can see transaction fee payment received, approval to transfer. Okay. It's kind of cool, right? Now we are waiting to get the approval to move the NFT using retain NFTC because we use the custom ERC20 token. Boom. And we got approval. That means that the NFT has been moved. Okay. NFT has been transferred to the bridge. Let's look for that message right here. There you go. In transit to destination. Here we go. This is the message that we are displaying. Okay. And now we got the RPC address transferring via destination via the RPC. And we got transfer completed. Transfer completed means that I was able to confirm that the destination NFT has been sent to the user wallet. And this is how an NFT bridge works. All this. We went through every single thing one by one. And you want to be a Web3 developer. Welcome to the club. Okay. Wallet refreshed. So I can show you wallet refresh. And now if you see here, I think that's the last message. Wallet refresh. Actually, no, this is the function in the source. Wallet refresh. There you go. There you go. Okay. Now, if I go back, let me close. This is all the information that I'm going to look for to know that I'm going over every single action in the function, right? So now let me go, and if I click transaction info, I'm going to open another tab, and I'm going to see the destination blockchain transaction being successful, and I see that I was able to move token ID 1, NFT collection token ID 1. Now I have it in Binance Smart Chain. So let's go back here. Let me close the model. And now you can see that I no longer have NFT number 1. Okay. And that's it. I am going to provide the code in GitHub. Okay. But you're not going to be able to use it yet until we do the front end. Once we do the front end, you're going to be able to play with this amazing work of art. Okay. But yeah, that's it. This is literally an NFT bridge. And yeah, happy coding. Sometimes I think why I like Web3. No, I love Web3. I love Web3. I love blockchain development. It's the future. It's not that I think it's the future. It is the future. It's just passionate to see amazing things that we can build, and we can allow this to happen. Okay? This is all it's about, to bring the creativity in your mind and also give you the tools that you need to get yourself on track in Web3 blockchain development. That's all we're doing in this channel. All we're doing. Okay? On the next video, I am going to code the Web3 front end, and we are going to connect the JavaScript function to the web interface. And after that, we just need to test. We are almost done with the NFT Bridge. But for now, that's it for this video. I hope you like what we're doing here, because this is no easy task. But like I said at the beginning, it's not impossible. Thank you so much for your support. I truly appreciate it. If you like this video, hit the thumbs up. Hey, subscribe if you haven't subscribed to. And we'll see you on the next video. Bye.